Okay, let's dive in. Today we're doing a deep dive focused on one specific piece of tech,
hmm
the DVDO C4-1-NDI WHD PTZ AI NDI camera. It's quite a name.
It really is. But it tells you a lot up front, doesn't it? PTZ, pan-tilt zoom, with AI smarts and built-in NDI for network video.
Exactly. AI-powered, multiple outputs. It seems like a modern production tool. And who's behind getting this to users?
Well, it's sold by HDTV Supply. They've been around, what, 24 years? A global name in AV. Google Shopping even rates them as an exceptional top-quality store, so, reliable.
Good context. So, let's talk about getting your hands on one. Price.
Currently listed at $1,699, and availability seems pretty good. The source says it usually ships the same business day.
Okay, quick turnaround. What about support if something goes wrong? Or returns?
Standard stuff, mostly. It comes with a 1-year manufacturer's warranty, and they offer a 30-day return policy, but only if it's unused and still in the box. Standard
Right.
procedure.
And they mentioned free USA shipping, which is always nice.
Definitely helps with the overall cost.
So let's move to the core specs. Image quality is fundamental. What are we looking at?
We're talking full HD, so 1920 by 1080 resolution, and importantly, up to 60 frames per second. That comes from a 12.8-inch CMOS sensor.
That 60 fps. Why is that particularly relevant for a camera like this? Thinking about its uses.
Well, think about online education or maybe telemedicine. You often get faster motion, a lecture pacing, or quick hand gestures in a consult. 60 fps smooths all that out, less motion blur, clearer picture.
Makes sense, especially when you combine that smoothness with the zoom. What's the zoom reach?
It's pretty impressive. You get 20x optical zoom. That's the crucial one, the high-quality zoom.
20 times optical.
Yeah.
Yeah.
And then on top of that, there's an extra 15x digital zoom if you need to push in even further.
So capturing details from far away, like across a lecture hall, is definitely possible. But with that much zoom, how do they keep the image, clean and stable? Noise can be a big issue.
Right. They emphasized the noise reduction. It uses both 2D and 3D noise reduction tech. The goal is a super high signal-to-noise ratio, or SNR, image.
Okay, break that down a bit. 3D noise reduction, how did that help specifically?
Well, 3D noise reduction looks at frames over time, so it's particularly good at cleaning up noise on moving objects without blurring them. Essential if the camera's tracking someone.
Got it. So the image quality is there. What about the PTZ part, the movement itself?
Yeah.
Needs to be smooth and quiet, right?
Absolutely critical. They mention using a high-accuracy step-driving motor. The idea is whisper quiet pan and tilt movements. You don't want mechanical noise bleeding into your audio during, say, a lecture recording.
Makes total sense. And the range of movement.
It's wide. Pan goes from minus 170 degrees to plus 170 degrees. Tilt covers minus 30 up to plus 90 degrees. So yeah, I can see pretty much anywhere in a room.
And I saw something about a gravity sensor for ceiling mounts.
Yeah, that's a neat touch. If you mount it upside down, the built-in sensor detects it and automatically flips the image and controls. Simplifies the setup quite a bit.
Okay, so solid mechanics and image foundation. Now let's get to what feels like the main event. Connectivity and the AI features. It has multiple outputs.
It does. You've got your standard HDMI and SDI plus USB 3.0, but the big one is the LAN port.
So why the LAN port specifically?
Because it enables simultaneous output alongside HDMI and SDI for video and audio. But more importantly, that LAN port supports PoE power over Ethernet.
Ah, okay, so one single network cable.
Exactly. That one cable can handle power for the camera, control signals, the video feed, and the audio. It massively simplifies wiring, especially for complex installs.
And that LAN port also enables NDI, right? Network Device Interface.
Precisely. NDI is huge for modern IP-based video production. So PoE plus NDI on one cable. That's a very streamlined, broadcast-ready connection.
Very efficient. Now the AI. It mentions built-in human detection. What does that actually do?
It allows the camera to automatically track a person in real time. Think lecture capture without needing a dedicated camera operator just to follow the speaker.
What kind of performance are we talking about for that tracking?
The specs given are a maximum tracking range of about 6 to 7 meters, and it's designed to keep up with someone walking at a speed of 3 to 4 meters per second.
4 meters per second. It's a pretty brisk walk, so it can follow someone moving quite naturally across the stage.
Seems like it, yeah. And you can fine-tune it. You can set up to 4 specific regional tracking areas, so you could tell it, ignore movement near a doorway or window, focus only on the stage area.
Smart. So who is this really built for? What are the ideal applications?
The source lists things like online education, definitely lecture capture, webcasting, video conferencing rooms, and even telemedicine applications. Anywhere you need high-quality video, Zoom, and potentially automated tracking.
And I noticed it mentions H.264 and H.265 compression.
Right, that's for the network stream. Supporting those efficient compression standards means you can maintain smooth video even if your network bandwidth is a bit limited, helps ensure reliability.
Okay, so wrapping it up. We have a camera with strong 20x optical zoom, multiple simultaneous outputs including SDI, HDMI, and crucially, NDI over PoE.
Backed by that quite speedy AI human tracking, capable of following someone walking up to 4 meters per second. It really bundles a lot into one unit.
It does. Which leads to a thought, something for you, the listener, to consider. This camera integrates multiple control protocols, common ones like Visca and Pelco, and those multiple concurrent outputs like NDI, SDI, HDMI. So the question is, how might this level of integration, putting all that power, control, and output flexibility into single devices connected often by just one network cable, fundamentally change the way we design and wire multi-room or multi-format production spaces in the future? What does it mean for traditional infrastructure?